Olympiad Prep Guide 5, Science, Chapter 8, Force and Energy. Force. Force can be defined as the push or pull that tends to maintain or alter the motion of a body in the direction of the force or to distort it. Force can be defined as the push or pull that tends to maintain or alter the motion of a body. That tends to maintain or alter the motion of a body in the direction of the force or to distort it. The direction in which the object is pushed or pulled is called the direction of force. Push and pull come from the objects interacting with one another. At least two objects must interact with each other for a force to come into play. Forces are used in our everyday activities. Example, a force is used when we pull a door. A force is used when we twist a wet cloth to squeeze out water, etc. A force can produce the following effects. It can move a stationary object. It can stop a moving object. It can make a moving object move faster. It can slow down a moving object. It can change the direction of a moving object. It can change the shape and size of an object. Yes, so a force can produce the following 6 effects. It can move a stationary object. It can stop a moving object. It can make a moving object move faster. It can slow down a moving object. It can change the direction of a moving object. It can change the shape and size of an object. The 6 effects a force can produce are 1. It can move a stationary object. 2. It can stop a moving object. 3. It can make a moving object move faster. 4. It can slow down a moving object. 5. It can change the direction of a moving object. 6. It can change the shape and size of an object. Olympiad Bite. All types of forces can be divided into two main groups: contact forces and non-contact forces. A force which can be exerted by an object on an other object only through physical contact is called a contact force. Example, muscular force, frictional force. A force which can be exerted by an object on another object even from a distance is called a non-contact force. Example, magnetic force, electrostatic force, and gravitational force. The types of forces. There are different types of forces present in nature. There are 8 types of forces. 8 types of forces. 1. Muscular force. The force exerted by muscles of our body is called muscular force. Lifting a school bag, kicking a football, pushing a door, etc. are some activities that use muscular force. The strong muscles of a weightlifter enable him to lift weights much heavier than an ordinary person can. A balanced diet, regular exercise, and outdoor activities such as running and playing can help us build strong muscles. 2. Frictional force. A ball rolling on the ground comes to a stop after some time. The observation indicates the presence of a force that opposes the motion of the object. This force that causes moving things to slow down and eventually stop is called frictional force or friction. It acts opposite to the direction of the motion of objects. It comes into play only when an object moves or tries to move over a surface. A rough surface offers greater friction than a smooth surface. So, friction can be reduced by making the surfaces smooth. The advantages of friction are: 1. Friction helps us to walk. If there were no friction, then we would just slip if we tried to walk. When we apply force in the backward direction by our feet, the force of friction acts in the forward direction and helps us to walk forward. 2. Without friction, we would not be able to hold anything in our hand. It is the friction between a pen and paper that allows us to write. 3. A pencil eraser uses friction to rub off mistakes. 4. The tires of a car or any other vehicle would just keep spinning if there were no friction between the tires and the road. Car brakes can be applied because of friction. The two disadvantages of friction are: 1. Friction makes it difficult to move heavy things across the floor. 2. Friction causes the soles of our shoes, the surface of tires, and moving parts of machines to wear out. 3. Mechanical force. It is a type of contact force applied by a machine. For example, cranes use mechanical force to tow away a bus, a car, or lift heavy loads during the construction of buildings, flyovers, and bridges. A pair of scissors apply a mechanical force while cutting a piece of cloth. A pair of scissors apply a mechanical force while cutting a piece of cloth. The engine of a train generates a large mechanical force that enables it to pull the coaches attached to it. Olympiad bite. When we rub a matchstick against the rough side of a matchbox, then friction between the head of the matchstick and the rough side of the matchbox produces heat. This heat ignites the chemicals present on the head of the matchstick, due to which the matchstick lights up. So the matchstick catches fire and starts burning. The burning of the matchstick would not be possible without friction. 4. Magnetic force. A magnet attracts metals such as iron. The screw is made up of iron, so when the magnet is moved, the screw follows it. The materials that get attracted to a magnet are called magnetic materials. The force exerted by a magnet is called magnetic force. Olympiad bite. A magnet has two poles, namely the north and the south pole. Opposite poles attract each other, while similar poles repel each other. 5. Gravitational force. The force by which the earth pulls objects towards itself is called gravitational force. When ripe fruits are separated from a plant, they do not float around or fly upwards. Instead, they fall down to the ground. Similarly, when a ball is thrown upwards, it comes down after some time. Why? Due to gravitational force. 6. Elastic force. A stretched rubber band regains its original shape on being released because of elastic force. Elastic force arises when a body deforms. Elastic force arises when a body deforms. Buoyant force. Buoyant, buoyant force. 7. Buoyant force. If we push down a mug or a block of wood floating on water, we feel an upward thrust. The upward push of water on a floating object is called buoyant force. The upward push of water on a floating object is called buoyant force. The upward push of water on a floating object is called buoyant force. This force acts on every object, even on you when you enter a swimming pool. 8. Electrostatic force. Electrostatic forces are attractive or repulsive forces between particles that are caused by the electric charges. Electrostatic forces are attractive or repulsive forces between particles that are caused by the electric charges. An electrically charged object can exert an electrostatic force on an uncharged object. An electrically charged object can exert an electrostatic force on an uncharged object. For example, a plastic comb which is electrically charged by rubbing in dry hair exerts an electrostatic force on uncharged tiny pieces of paper and attracts them. The 8 types of forces are muscular, frictional, mechanical, magnetic, gravitational, elastic, buoyant, electrostatic. Muscular, frictional, mechanical, magnetic. Muscular, frictional, mechanical, magnetic. Muscular, frictional, mechanical, magnetic, gravitational, elastic, buoyant, electrostatic, gravitational, elastic, buoyant, electrostatic. The 8 types of forces are muscular, frictional, mechanical, magnetic, gravitational, elastic, buoyant, electrostatic. Energy. Energy is the ability to do work. Energy is everywhere in nature. Sunlight, wind, water all possess energy. We use energy every day, but we cannot see energy. Only its effects can be seen. Here's a riddle. You cannot see me, but you can only see my effects. Who am I? You cannot see me, but you can only see my effects. Who am I? I am energy. The different forms of energy. We had 8 types of forces and we have 9 different forms of energy. 1. Mechanical energy. Mechanical energy is the energy which is possessed by an object due to its motion or due to its position. Mechanical energy of an object can be either kinetic energy, energy due to its motion, or potential energy due to its position. Kinetic energy due to its motion, potential energy due to its position. The more is the height of an object from the ground, the more is the potential energy it possesses. A moving car possesses mechanical energy due to its motion, kinetic energy. 2. Heat energy. It is a form of energy which is responsible for the sensation of heat or coldness. We get heat energy from the sun and also by burning various fuels like wood and coal. This energy is useful in cooking, running steam engines, and generating electricity. 3. Solar energy. Solar energy is the most readily available source of energy. It is the most important source of energy because it is non-polluting. It is used by plants for photosynthesis. When we hang our clothes to dry in the sun, we use the energy of the sun. Similarly, solar cookers absorb the energy from the sun to provide heat for cooking. Solar panels produce electricity with the help of solar energy. 4. Light energy. Like heat, light is also a form of energy. It makes things visible to us. It travels as waves. It enables us to see things around us. Light energy can travel through vacuum. The sun is the main source of light for us. We also get light from stars, bulbs, torches, candles, etc. Here's a riddle. I make things visible to you. I travel as waves. I enable you to see things around you. I even travel through vacuum. Who am I? Light energy. 5. Electrical energy. Electrical energy is the movement of electrical charges. Electrical charges moving through a wire is called electricity. Electrical charges moving through a wire is called electricity. Most of the appliances that we use these days, like washing machines, televisions, computers, tube lights, bulbs, and fans, run on electricity. Here's a riddle. There's a city in my name, but I'm not a city. I also make things run. Who am I? I'm not a coach. I am electricity. 6. Sound energy. Many objects such as musical instruments, firecrackers, and aeroplanes produce sound energy. It is produced when force makes an object vibrate. Sound energy is produced when force makes an object vibrate. Sound energy travels through solids, liquids, and gases as waves. It needs medium to travel. It cannot travel through vacuum. It travels fastest in a solid medium and slowest in a gaseous medium. The energy of sound is far less than other forms of energy. 7. Geothermal energy. The word geothermal comes from the Greek words geo, earth, and thermi, T-H-E-R-M-E, thermi, heat. So, geothermal energy is heat from within the earth. We can use the steam and hot water produced inside the earth to generate electricity. Geothermal energy is a renewable energy source because the water is replenished by rainfall and the heat is continuously produced inside the earth. There are places on the earth in some countries where this hot water comes out of the earth, and these springs are called geothermal springs, and people bathe in these geothermal springs for medicinal effects. 8. Hydro energy, that is water energy. Hydro means water. Hydro energy is the energy obtained from moving water. Earlier, people used this energy to move a paddle wheel that would grind the grains. Now, it is also being used to produce electricity, which is known as hydroelectricity. The power station is called hydropower station. It is a renewable and non polluting source of energy. 9. Wind energy. Wind energy is plentiful, renewable, widely distributed, clean, and non polluting. Therefore, it is considered by experts to be more environment friendly than many other energy sources. Wind power is the conversion of wind energy into a useful form, such as electricity, using wind turbines. So, yes, a wind turbine is used to generate electricity from wind energy. In windy places, you will see a field of wind turbines. And due to the constant wind, these wind turbines are always with moving blades. Olympiad bite. Energy can neither be created nor can it be destroyed. It can only be converted from one form to another. This is known as the law of conservation of energy. For example, when we switch on a ceiling fan, the electric energy gets converted into mechanical energy of a fan and a small amount of heat and sound energy. The 9 different forms of energy are 1. Mechanical energy, 2. Heat energy, 3. Solar energy, 4. Light energy, 5. Electrical energy. 1, 2, 3, 4, 5. Mechanical, heat, solar, light, electrical. Mechanical, heat, solar, light, electrical. Mechanical, heat, solar, light, electrical. 6. Sound energy, 7. Geothermal energy, 8. Hydro energy, 9. Wind energy. 6, 7, 8, 9. Sound, geothermal, hydro, wind. Sound, geothermal, hydro, wind. Sound, geothermal, hydro, wind. The 9 forms of energy are mechanical energy, heat energy, solar energy, light energy, electrical energy, sound energy, geothermal energy, hydro energy, and wind energy. Simple machines. A machine is a device or a tool which helps us to do work easily, efficiently, and quickly. Some machines have very few parts and a simple structure. They are called simple machines. The machines that have very few parts and a simple structure are called simple machines. Simple machines do work either by changing the direction of force or by reducing the effort needed. So, how do simple machines do work? In 2 ways, either by changing the direction of force or by reducing the effort needed. Some examples of simple machines are lever, inclined plane, wheel and axle, pulley, wedge, and screw. Let us learn about 6 types of simple machines. 1. Lever. A lever is a simple machine consisting of a beam or rigid rod pivoted at a fixed hinge or fulcrum. Fulcrum. It is free to rotate on the fulcrum and is perfect for lifting or moving heavy things. For example, in order to move a big stone with hands or with the help of a stick, a person needs to apply a lot of force. But if a small stone is kept as a support below the rod, very close to the stone, and the person uses downward force on the other end of the rod, the rock is lifted upwards. Here, the rod is a lever. The weight lifted by the person is the load. The point of support or the pivot point of the rod where it touches the small stone is the fulcrum, Fulcrum. The force used is the effort. Some examples of levers that we use in our day to day life are hammer, tongs, scissors, pliers, and nail clippers. Levers can be classified according to the position of the fulcrum, load, and effort. Levers can be classified according to the position of the fulcrum, load, and effort. Remember, the position is important. So, how are levers classified? Based on the position of the fulcrum, load, and effort. They are classified as first class, second class, and third class levers. First class lever. In first class lever, the fulcrum is in between the effort and the load. Scissors, crowbar, pliers, and seesaw are examples of first class levers because the fulcrum is in the middle of the load and the effort. Second class levers. In a second class lever, the load is in between the fulcrum and the effort. Here, the load is in the middle in the second class lever. Bottle opener, nutcracker, and wheelbarrow are examples of the second class lever. In a second class lever, the fulcrum is at one end and the effort is at the other end, and the load is in the middle. Like the wheelbarrow, the fulcrum is the wheel, the load is the stuff in the basket of the wheelbarrow, and the effort is you holding the handle of the wheelbarrow. In a nutcracker, you holding the two ends of the nutcracker is the effort. The screw at the end of the nutcracker is the fulcrum, and in the middle is the nut, which is the load. So, second class lever are levers in which the load is in between the fulcrum and the effort. Like in the bottle opener, nutcracker, wheelbarrow. Third class lever. In third class lever, the effort is in between the fulcrum and the load. The effort is in between the fulcrum and the load. Tongs, tweezers, fishing rods are examples of third class levers. In an ice tong, for example, the ice is the load, it is at the end of the tong. The fulcrum is the other rounded joined end of the tong, and the effort, you hold the ice tong in the middle, that is, the effort is in the middle. So, an ice tong is a third class lever. 2. Pulley. The second type of simple machine is the pulley, Pulley. A pulley is a small wheel with a groove around its outer edge. The groove can hold a rope in position. A pulley together with a chain or a rope is used to lift objects. A pulley together with a chain or a rope is used to lift objects. There are two types of pulleys, fixed pulley and movable pulley. Fixed pulley. In this type of pulley, the wheel is attached to a hook or a wall and spins at one fixed place. A fixed pulley changes the direction of the force. A fixed pulley changes the direction of the force. For example, we can pull down in order to lift something up. It makes lifting objects convenient, but does not reduce our effort. A pulley used to draw water from a well is an example of a fixed pulley. In a fixed pulley, the effort should be equal to the load lifted. In a fixed pulley, the effort should be equal to the load lifted. Why? Because a fixed pulley makes lifting objects convenient but does not reduce our effort. A movable pulley. In this kind of pulley, the wheel also moves with the load. Here, the effort needed to lift the load is reduced by half. This lets us lift objects that would otherwise be too heavy for us to lift. However, we need to pull twice the length of the rope. Also, the force is applied in the same direction as the load. The force is applied in the same direction as the load. This means to lift a load, we need to pull the rope in the upward direction. A pulley used to lift heavy engines and fit them into vehicles is an example of a movable pulley. A pulley used to lift heavy engines and fit them into vehicles is an example of a movable pulley. Just a thought. Because we pull, Pull, it's called a pulley. Why is a bully called a bully? Is it because he or she acts like a bull? The third simple machine, the inclined plane. An inclined plane is a slope or a slanting surface which connects a lower level to a higher level. It helps to move heavier objects to a height. An inclined plane does not reduce the amount of work done but makes it easier to do. An inclined plane does not reduce the amount of work done but makes it easier to do. Children slide in a playground, ramps for wheelchairs, and sloping roads are some examples of inclined planes. The fourth simple machine is the wheel and axle, AXLE, axle. The wheel and axle has a large wheel connected to a small rod called the axle. The axle is the rod. The two are fixed so that they move together. When the wheel is turned, the axle also moves. The steering wheel, STEERING, the steering wheel, the screwdriver, and bicycle pedal are examples of a wheel axle arrangement. The fifth simple machine is the screw, SCREW. A screw is a simple machine used to hold things tightly together. When we join things together with a screw, they are held together through a longer distance and thus cannot be forced apart easily. A screw is a modification of an inclined plane. It is formed when an inclined plane wraps around a straight rod-like structure. Think about this. A screw is formed when an inclined plane wraps around a straight rod-like structure. Take a screw and observe this. A screw has a spirally grooved surface with a pointed end. The head of a screw also has a groove, that line in the middle that you see. The screwdriver is fixed into this groove and rotated. Due to spiral grooves, the screw moves into the wood easily, and so a screw holds the wood more firmly than a nail. There are two types of screwdrivers. One is a flat screwdriver, which goes into screws that have only one groove. The other type of screwdriver is the Phillips screwdriver. The Phillips screwdriver has a sort of a cross because it goes into two wedges at the head of the screw. The sixth simple machine is the wedge, WEDGE. WEDGE. A wedge is an object with two inclined planes ending in a sharp edge. The sharp edge is used to cut materials. Examples of a wedge include razor, axe, and the knife. We have one wedge in our very own body. Can you think where God has put this wedge in our body? There are 8 of these wedges put in our mouth. Yes, they are our incisors. Our incisors are wedge shaped. That is why they are used to cut. Let's revise the 6 simple machines. 1. Lever. First class lever, second class lever, third class lever. 2. Pulley. Fixed pulley, movable pulley. 3. The inclined plane. 4. The wheel and axle. 5. The screw. 6. The wedge. Thank you for learning about force, energy, and simple machines. Thank you, Lord.